To find the critical points of an implicitly defined function, we always start by using implicit differentiation to take the derivative. Then we simplify the equation, eventually rewriting it so that we can solve it for y prime. And then once we have the equation solved for y prime, we set that derivative equal to 0. Now, 4x minus y equal to 0 would make this equation true, and 2y plus x equals 0 would make this equation undefined, so we investigate both equations and solve them both for y. Then we take each value that we find and plug it back into this original equation. Now here, we're plugging 4x back into the equation, and we find x equals 0. Plugging that x equals 0 value back into y equals 4x gives y equals 0, which means that we put x equals 0 and y equals 0 together to get the critical point 0, 0. If we do the same thing with y equals negative 1/2 x, we find the same x equals 0 and y equals 0 values, which leads us to the same critical point, and that's the set of steps we follow every time to find critical points of implicitly defined functions.